Good morning, bachcho. In the previous session, we had discussed about the geometrical and optical isomerism in case of tetrahedral complexes. In today's session, we will discuss about the geometrical isomerism in octahedral complexes. We know that there are 6 ligands attached to the central metal atom in case of octahedral complexes. Now, these 6 ligands may have different configurations, like we start from Ma6, where all the 6 ligands are identical. So, in this case, there will be no geometrical isomer. And Ma5b, here 5 ligands are identical and one is different. Then also, it will not show any geometrical isomerism. Now, we go from A4 to A3 to A2 and finally M, A, B, C, D, E, F. Okay, which has 15 geometrical isomers. So let us go from Ma4B2. It has 2 geometrical isomers. Ma4BC has 2. Then Ma3B3 will have 2 geometrical isomers. Now it will start increasing. Okay, so Ma3B2C 3, Ma3BCD 4, Ma2B2C2 5, Ma2B2CD 6, Ma2BCDE 9, MABCDEF 15. So just you can remember this. We have made various combinations like Ma4B2, then we break B2 to BC, so Ma4BC, then Ma3B3, then we break B3 to B2C, then we break B2 to BCD, then it will be Ma2B2C, then we break C2 into CD like this, and Ma2, then B2 will break into BCDE. So this way we can remember. Okay. Now Ma3B3 is a special case because it shows 2 types of geometrical isomers. They are called meridional isomers and facial isomers. So meridional isomers are those, these isomers have 3 identical ligands like AA. These 3 A's are present in the equatorial plane. Okay, and in case of facial, the 2 A's are present in equatorial plane and 1 A is present in the axial plane. So okay, now here we can also say that this is the transform. Okay, why trans? Because the angle between 2 A's is 180 degree and angle between these 2 A's is 90 degree. So when the 2 A's are at 180 degree apart, then it is called transform, and when all the 3 A's are at 90 degree to each other, okay, then it is the cis form. This is also called cis form. That is the facial. Okay, so we can also say that in facial, this all the 3 A's are at 90 degree to each other. Okay, even though one is in the axial plane and 2 are in the equatorial plane. And in this case of meridional, this 2 A's are at 180 degree to each other. They are far apart. So the angle is not 180 degree, is not 90 degree among all the 3 A's. Here the angle among all the 3 A's is 90 degree. Okay. Now these are both optically inactive because there is a plane of symmetry present. So there is no chiral central metal atom. So both the forms are, that is both the meridional and the facial, both these are optically inactive because of the plane of symmetry. You can see here the 3 A's are in the same plane, so it will have a plane of symmetry. And in this case, if you go A and B, then you see both sides there is a plane of symmetry. So they will not show optical isomerism. Thank you and wish you all the best.